Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
So, Pratham, do you remember that phase in school or in the world when everyone thought robots would either take over the world or help us with homework?
Hello, people still think that's gonna happen.
Wait, which one? Like the world ending or the world being aided by robots?
Both of them. I'm just
I
waiting
mean-
for a robot to do my laundry. But you know what? No one ever talks about bendy robots.
Ah, yes. Similar to bendy machines, hint, hint, compliant mechanisms, which we may have done an entire episode 27, a while ago on. And these, we are not talking about like the Terminator type metal robots that are rigid and strong like steel, but like we're talking about the ones that are literally soft. Now, they aren't soft like the advanced T1000 Terminator robot that becomes liquid and then reforms in the movie. It's like in actuality, the ones we are talking about are made up of fabric and air. They're like soft robots called kind of like balloons.
Huh? So you're telling me that there are more robots out there there are robots out there that are built more like balloons than electronics?
Yeah, and just like things that bend or bounce like robots,
Bounce.
like balloons,
Balloons.
they have actual advantages. Like
Okay.
for starters, they are safer. You
Yeah.
know how pointy and like hazardous pointy robots are around people?
Yeah, that reminds me of the Boston Dynamics robot. One wrong backflip meeting the face of a bystander and boom, facial adjustment.
Exactly. Now
Don't
imagine
even
a
need
robot.
Botox for this.
Now imagine a robot that's more like a bouncy castle rather than a walking, I mean, what, tank?
Tank.
And
I
like,
see.
if it falls on you, it won't crush your ribcage instantly and kill you in a horrible way. That's why soft robots exist for flexibility, safety, and working around humans and children without breaking things or people. No collateral damage.
So how do they even work? Like, you can't exactly shove a bunch of wires and circuits into a balloon, right?
I mean, that's the fun part. A lot of them don't even use electronics inside. Instead of electricity, they use air, compressed air to be precise.
Wait, like pneumatic systems?
Yeah, exactly. So, literally, pneumatic systems, I mean, some of them will be based on electricity, but like they'll be powered by electricity, not
Oh,
based
yeah,
on
yeah,
it
yeah. I got
directly.
it. That's nice. So we can think of like the tubes made out of fabric or flexible plastic, and you inflate them, and now they hold a shape. You can then control how much air goes where, and boom, you get some movement.
So it's kind of literally like twisting balloon animals, and you're controlling how much air there is, that which controls the pressure. Except it's an actual robot that you control it with precise machine instruments.
Yeah, yeah, pretty much. There was one I saw, a soft robot shaped like an octahedron. Like it's a fancy eight-face shape, basically.
Like the eight ball.
Eight-sided polygon.
Yeah.
No, not
Not
the
the
eight
eight ball is a ball. It's a
spherical.
sphere. I know, but like sounds nice.
No, okay.
Yeah, it's octahedron is just an eight-sided like shape. That's it.
Basically, this had four tubes forming triangles. Motors squeeze the tubes at certain points, and they
And
bend.
there was dices.
Yeah, they bend them, and they make the whole robot change shape.
And that sounds something like straight out Big Hero 6. I'm getting Baymax vibes. Like,
You're not that far off, you know. In fact, that movie actually got a lot of people interested in this field.
wow.
Yeah, real life soft robots can change their shape, get taller to go over stuff, or even squish down to fit under obstacles.
Okay, yeah, that like I agree with all of that, but what's the point of all of it? Like, why not just use a normal robot that doesn't bend and is stronger, technically speaking?
Yeah, so basically, I read that there are two big reasons. First is, of course, safety, like we discussed. Second is adaptability. Imagine a robot that can squeeze into places hard robots can't.
Like, can go through any hole or anything.
Yeah, like navigating through collapsed buildings during some rescue missions, or maybe exploring inside mines where electronics might like spark explosions, maybe.
Yeah, and as we said earlier, there are technically no electronics in there because it's just air. Like, it is so low tech that it loops back around to being high tech, kind of. Like, it avoids all the high tech problems
Yeah.
like of electronics in mines, for example, that might spark explosions. We've spoken about it earlier as well, like where a small spark can echo, so-called echo, like domino throughout the entire mine and cause everything,
Yeah.
all of those explosive gases to explode. And it's confusing but also brilliant, and that's why these machines that are soft machines are so smart and brilliant, because some soft robots use purely pneumatic logic, like no wires, no sparks, perfect for places where electronics would be dangerous.
Yeah, it's just like Occam's razor. The simplest way is always the
Always the
best way.
best.
Yeah. But let me get this straight. They're inflatable tubes filled with air. But what if something pops? Like,
Yeah,
that's
that's
very
literally
possible.
the big risk. Like
Yeah.
that's why it's not that strong. Like you get a leak, no more robot. You get a hole in it, like one small pinprick,
Gone.
no more robot. It's like literally like Baymax, except you don't have the self-healing capability, like where it
Yeah.
patches it up
Yeah.
itself up. It's not smart enough to do that yet. But they're working on solutions like having onboard compressors to keep this pressure stable even with minor leaks.
Yeah,
Minor
it
leaks though, not
makes
major
sense.
ones.
Makes sense. And because they can change shape, they could be useful in space too. Like, I think NASA has looked into this. You know how space missions have crazy volume restrictions?
Yeah, yeah.
Yeah, a robot that packs small on Earth and takes basically no space in the rocket and then expands big when it's like out on lunar or
Any
Martian
planet, yeah.
surfaces, and then it can adapt to those weird environments. That's really cool, right? It's basically the ideal way to explore nearby heavenly or celestial bodies.
Yeah, and that's like the most efficient and cost effective way right now for us. And it's
Yeah.
next level. It's like the robot version of a camping tent. Small in the backpack, massive when set up.
That's actually like almost a perfect analogy. Plus, they're thinking about using soft robots to pick things up and grasp objects, kind of like how an octopus uses its tentacles.
Ooh, nice. Nature.
Yeah,
Using nature's ideas,
biomimicry.
biomimicry.
The tubes bend just slightly to wrap around stuff gently, you know?
Yeah, and an octopus robot, now that I'd pay to see.
Yeah, they've even given them like weird sausage name like Polish, chorizo, and linguica.
Huh?
Yeah,
What
because
is that?
when these inflated tubes are put together, they look like giant sausage links, and the color of the tubes are like the color of sausages. So
Okay, I'm sorry, but if I ever see a sausage shaped robot rolling towards me or even like waddling or anything towards me,
modeling.
I'm running the other way. I'm not paying to see a sausage robot. Octopuses are fine.
I mean,
Octopi.
you wouldn't need to. It would probably just bounce off of you.
Yeah, it's like a balloon. Fair.
Yeah, these things can only exert a limited force because they're flexible, and that makes them safe for working alongside us humans.
I mean, that's true. Now, safety was always a first priority, but how strong are we talking though? Like, can they actually carry real loads to be usable in real fields in the real world?
I mean, surprisingly, yes. There's a control system, usually through software like MATLAB.
Matlab? MATLAB, MATLAB, yeah, MATLAB.
Yeah, where you can basically punch in positions and the robot moves exactly where you want. It's not as precise as rigid robots, but it's still very capable.
I mean, I feel like this is one of those things that sounds super niche now, but it's going to be everywhere in 10 years. And also, like, this will just keep getting better as the software and the algorithms that define those robots' movements improve to become more precise. It may just become as accurate as and as capable as a rigid robot
Yeah,
in terms of
definitely.
movement.
Especially with robots getting closer to humans, think like service robots or medical robots. Having them soft just makes sense.
Give it time. Also, shout out to the grad students building those things by hand, like from various of these top universities.
Yeah.
They can take up to a month to assemble. Like they have to like literally sew the fabric tubes. Like if you're making one at a time, you have to like sew fabric tubes, inflate them. Like that's easy, like just cycle pump kind of thing, and then set up the motors. But that's like really hard work.
Yeah, respect to them. Though I'm curious, why not just like build everything out of metal?
Yeah, use real life adamantium like in Hacksmith Industries on YouTube. I don't know what it's called, but it's really strong. Because now to answer your question, sometimes software is better. It's not always about brute force. Sometimes it's about being adaptable, safe, flexible, literally and figuratively.
You know what's crazy though? The contrast. Like on one hand, you've got this Boston Dynamics dog and
Dog, yeah.
yeah,
All of these like Atlas
doing
robots,
doing
backflips, na?
backflips and
Yeah.
sprinting, and then you got these chill squishy robots rolling around like the soft toys, just waiting for a hug.
I mean, literally, that's literally exactly the point, right? It's two sides of the same coin. Hard robots for precision and strength, soft robots for flexibility and safety.
Until then, squishy robots, they're not just balloon animals, but they're the future of robotics.
I mean, I guess everyone would take that over robot overlords any day.